Number 59 in Chapter 8 is looking at effective nuclear charge. And the question asks us if core electrons completely shielded valence electrons from nuclear charge, and if valence electrons did not shield one another from nuclear charge at all, what would be the effective nuclear charge experienced by the valence electrons of each atom? And so I'm just going to do part A and part C here, which looks at potassium and oxygen. And what we're trying to calculate here is Z effective. And Z effective is essentially the effective nuclear charge, the effective positive charge that the valence electrons actually feel. And so remember, what is that effective nuclear charge based on? Well, the first thing it's based on is the atomic number, right? The actual number of protons that are in the nucleus. And then we want to subtract away from that the shielding electrons. So basically we have our number of protons that we get from the atomic number, or Z, and then we have our shielding electrons, which are really our core electrons, right? So these are the electrons that have already filled up a quantum level. And so the difference between the core electrons and the number of protons will then tell us what the outermost electrons in the valence shell, what is their effective positive charge that they actually feel. This is another value that we can get from the group number. Not only is the group number a way to know right off the bat how many valence electrons there are, it also tells you what Z effective actually is. And so for potassium, if we're calculating Z effective, we see that potassium is in group 1A, and we already know from nomenclature early on that potassium likes to have a +1 charge. That's really describing Z effective. And so if we calculate what Z effective is for potassium, potassium's atomic number is 19. So that means it has 19 protons in the core, but there are 18 shielding electrons that are blocking the nucleus from the valence electron, and we end up with a Z effective of +1. So Z effective could also be determined by, again, looking at that periodic table and looking at the group number. Now let's look at oxygen. Oxygen is in group 6A, and so we know that it likes to gain electrons. It doesn't like to be positive, it actually likes to be negative. But given what we said earlier, if this is group 6A, then we would reason that the Z effective, the actual charge that these valence electrons see, is going to be +6. And let's see if that is the case. We take our Z effective, which we're trying to solve for. We see that oxygen has an atomic number of 8. Its core electrons only equals 2. And so the Z effective that the valence electrons feel is actually +6. So not only is the group number the number of valence electrons, potassium has 1 valence electron, that's why it's in group 1A. It also has a Z effective of +1, that's also why it's part of group 1A. Oxygen has 6 valence electrons, that's why it's part of group 6A. And also its Z effective is +6. Again, why is it in 6A? So these group numbers are really beneficial to keep in mind because they can help us with valence electrons, and now they can also help us with effective nuclear charge. That's number 59.